Can you see this now? You see
Yes,
this?
sir. I can
SPSS.
see.
Yeah.
Yes, and all my imputation is 3.
Uh,
Sir, can you tell me
the invasion.
what's
Oh,
the
this is the
imputation for?
trick. Do not this is not
And
important. This is nothing. Can you see my screen? Yeah. The imputation is I just make
yes,
it
sir, I
like
can
a
see.
funny thing for student to get worried because this is nothing to think about. Nothing about imputation. One of
Mm.
your friend
You put it for
uh,
fun. I dreamt about it. I dream
oh no,
when I slept.
because
I
I
dream of
cannot imagine.
imputation because I read about imputation
Uh,
before I
I
sleep. I
cannot
study all
imagine that you
imputation.
get
Where can
too
I
much
use
worry. I
imputation?
just make it
So
for fun for some students who like do not do not care too much about statistics, so they will they will do not know. They don't know what is that. And actually, I didn't ask about the imputation. I asked about the pH value and the zone. That is my question. I didn't talk about the imputation yet. Mm. No.
yes, sir, but yeah, you didn't talk about
No.
imputation, but if you will read about the meaning of imputation, if
No.
there will be missing values, if there will be like other stuff in
Mm.
regression, that imputation has, and then I just wonder why is the
Mm.
imputation has one value? Because the definition of imputation is like
Mm.
replacement or substitute of values, but why I do
Mm.
have one value and why is it 3?
Mm.
It's beyond, it's
Oh.
extreme,
Oh,
it's
I'm
not
so
within the
sorry.
range of my
I'm
pH
so sorry about that. Uh,
value.
I just
Anyway,
very
you
important
got me
for some
there.
students to
For
think about because I think
so,
today is long time for
it's
students
okay.
to take the test. I think that's too much time. But I just would like to add some more confusing for students to think about. Maybe they take some time to think about imputation. But I cannot imagine that you think too much to get too worried about the imputation. Can you
Okay,
see this? See
so
my
you will
screen? Can
show
you
me
see
the
my screen?
SPSS now?
Okay, you can see the SPDS now, right? Okay. You the
Yes, I
question could
can.
like to know if the different zone have different pH value, right?
Yes.
Right? Yes. So the first thing we need to check the first thing normal
Yes. Yes, sir.
normality. Normality that the assumption. So then we make decision. So in case of I told everyone in the question that I three
Yes.
zone. You can see 1, 2, 3 zone. So in case of three zone like this,
But
so you cannot
ANOVA,
use t-test.
it
You need
has
to
three
use one
level,
way
three
ANOVA
groups,
to yeah,
independent variable.
three groups. So yeah. And that when you can make decision, you are going to use one way ANOVA. So you need to find out what is the assumption of one way ANOVA. So the assumption could be something that I see.
Actually, sir, I did normality
Assumption.
test 2 times
Yeah.
because I read that we should do outlier first. So what I
Mm.
did normality test and then I did outlier and then I did normality test
Mm.
again just to make sure that my data is really normal before and
Mm.
after outlier is removed.
Mm.
Yeah. So
Mm. Mm. Okay, that's okay. So we check outlier first. We can do that. We can check outlier
yes,
first. Okay. Check the outlier first.
descriptive,
And then okay, we check outlier. So if we check
explore,
outlier, go descriptive, and go
mhm,
to yes, explore. And we select here,
factor list.
and then
Yes,
we select
correct.
zone to
And then
factor list
plots and
like this.
options.
Yeah. Yeah, yeah. This is normality. Sorry. This, okay, we check outlier first. Let me see. Outlier
Yes.
here. This outlier,
Yeah.
right? Outlier. We
We
are
could
going to
also
check
put
outlier first. Yeah,
I put
yeah.
the histogram just to also see visually the normal curve in plots. Yeah.
Yeah, yeah.
And
We can see the normal plot
then the
here. Yeah,
histogram,
we can do
yes.
that at the same
I did
time.
like
Yeah,
that.
like this.
Hmm.
Yeah, like this. Okay, that's okay. Click
Yes.
OK, and then we click OK again. Yeah,
I actually click, sir,
and we will
the
see the output.
descriptive just for me to see also the kurtosis and skewness
Yeah, yeah,
because I also
yeah. That's fine.
computed
Yeah.
manually. See my kurtosis and my skewness.
Mm-hmm.
I computed manually to make sure it's plus
Let us
minus
see.
2.58, and then it
Mm,
will give me
mm,
normal or not normal. So
mm,
so normality.
mm. So Michelle, we go back to the printout.
Yeah.
Can you see my screen?
Yes.
Okay, we
Explore.
got it. Can you see this? So
Yes.
this is
Yes.
the
Test of
yeah,
normality.
normality. So suddenly we see the significant.
Shapiro will.
Yeah, this is no problem.
It's all great.
All
Yeah.
yeah,
It's all greater than 2.05
yeah. This is all okay.
significance
So
level.
three group, this is all okay. No problem, right? Yeah,
All
all
normal.
normal. So and then we,
Yes.
we look at the outlier. We can see the box plot. Box plot. Yeah, yeah. So the
Yes.
first one is this one.
The box plot have I memorized her 46, 199 to 36
Okay,
to 39 to 20 to
okay.
21. See, I memorized
Yeah,
already. I watched it many times.
okay. So you
So
tell me to delete that. What is the first one?
yeah, it's
46.
46,
Wait a minute.
199,
46. Yeah.
case
Okay,
number
46. I delete
46.
46. Uh-oh, cannot do this because it moved. Uh, uh,
It's okay, sir. I actually do two times. One is I put the case number on the analyze by. If you press the and anyway,
yeah,
the
yeah,
next is
yeah, yeah. I know this. I
199.
know this.
So
What?
I just follow the
Okay.
case
What is
number.
the next?
So
What is the
yeah,
next one? 46 and 199 here.
199,
Okay.
199. So it should be
199 here.
198.
Okay, I delete it. And then
Yes,
what's the next?
yes. 295.
295. 295
So it should be 293.
here.
Yes.
Delete it. And then that's
Yes. And then 220 and 220. 239.
239. You not, let us see. 199.
It should be
199
yeah. Then
and
239.
220, 220 and 221. 199.
And 239, sir, on
Yeah,
top.
yeah, yeah, yeah.
239.
199 first. 199. 199 already, and then 220.
Yes. 230. Yeah,
220 and
220.
221.
221, yes.
And then
And then
239.
239. Yes. They
Hmm.
they actually arrange it by pH value, ascending value of pH, not by case
Hmm.
number. Yeah, okay, that's one. So we have one for zone 1, one for zone 2, and 4 for
That's
zone
all.
3. 4 for zone 3. And then if you do again the
Hmm.
outlier,
Yeah, we can try again.
yes,
Yeah,
this, yeah,
the same. Everything the same.
explore.
Delete that again.
Yes, everything the same, or you can untick, so there will be lesser
Okay.
things to see. It will be case number 218 and case number 236.
You will have two more, right?
Yes, yes, two. Yes, it's case number 218
No,
and case number
no, this
236.
is different.
These actually
In
are
my
the
case,
number in the
216 and 232. Yeah.
6 232. Yes, sir. But 216 and 232 is the number on the side, but the case number is
Mm.
different. So if you go to analyze, then go
Mm.
to descriptive to explore. Below the factor analyzed by the case number, because I actually ran it twice.
Yeah.
Can you please go to analyze? I if you go to analyze, then
Uh-huh.
same
Uh.
descriptive, then explore, and then if you put the case number in
Uh-huh.
label cases, yes, if you put your there, put case number in label cases, it will give you 218 and 236, and
Uh.
they are the same value. It's the 4.48 pH and the 3.87 pH.
So it's the same with this, with the same with 216 and
This number,
232. So we don't need to
yeah,
do this. It's the same
yes,
thing.
because
Now we should delete two of them.
yes,
Yeah, 216. We go
216
back
and 232, yes, sir.
to the data. 216. This one.
Yeah, so 216 is actually
Yeah,
the
right.
218 case
216
number.
delete. And
Yes. And then the 232 or the 231 is
32.
actually the 236 case number,
Yeah.
because we already deleted
232.
on top minus 1, 231.
232.
That one. So it's 236 case
231.
number.
Mm-hmm. Yeah, right. This one. Delete it. Okay.
Yes, sir. And then if you run
Check it.
again, there will be an
Check it
outlier
first.
again. Yeah, and then it's 204, which is case number
Really?
206.
204. Yeah.
So, and then,
200,
sir,
204.
have
Okay,
again.
we can go.
I actually try to get, yeah,
Mm.
204. Case number
No, 204. Oh, yeah,
206.
right. Right. Yeah.
Yes,
Delete it.
case number 206.
Delete again.
Yes, sir. Then there will be another two,
Mm.
275 and 218, which is case number
Mm.
83 and 224. And then, sir, I think the reason
Mm.
why they cannot show all together, because the number are
Mm.
very close and there is no space. Yeah, it's 275 and 218, which is case number
Mm.
283 and case number
Mm.
224.
Mm.
So all in all, I deleted
Okay, okay. I would like to delete again.
11 outlier.
So 218,
Yes,
218,
yes, 218 and 275. Yeah,
225,
224 case
225,
number.
and
And 274. 275, 274.
275, mm,
75. Yep,
275.
minus 1.
This one. Yeah. Mm.
274, yes, 283 case number. So that's it. 9
Mm.
outlier for
Let us check.
zone 3.
No, no more. Now it's okay. So,
Yes,
yeah,
that's now okay. Yes, and then we now check the homogeneity of the
this
variance.
one.
Is that correct,
The
sir? Or
the
do we need
this
to
one
do
normality
other
is
tests
alright.
before that?
You can see
Outlier.
outlier is okay.
Yes,
So that means now
and test for
we can
outlier is
analyze
also
the data. The
okay.
data is okay. Yeah. So that means now
The
everything
homogeneity
is
variance.
okay. The assumption is passed.
Mm,
Mm, the assumption passed already. So this data is acceptable
yes,
at this time. Mm. So do one
yes.
way ANOVA. Yeah.
So we now do
And this is the PS and
ANOVA.
so on become factor.
Yes.
And then we option. Option in case of you would like to the
Factor.
descriptive, that's okay.
Yeah.
The one, yeah,
Mm,
one thing that you need is homogeneity of variant test.
descriptive.
Yeah, we
Homogeneity of
uh
variance. Yes. For
Levin
the
test.
Levin's
Yes,
test, right,
this one
sir?
is the Levin test.
It's the
You
Levin's
test
test.
if the variant between group is the same or different.
Yeah.
Levin test. So that's okay now. We can click continue now. Yeah,
Yes.
yeah.
Yes. And then my significant
And then okay, we can test now in case of you are the new computer, the new analyzer, the new analyzer. You can click OK now. However,
yes,
if
sir.
you expert, you can click post hoc now, but that's okay. I will let you know later. Now you
Yes, sir.
OK. Yeah,
Yes.
we click OK.
I
Mm,
actually did, sir. I click
mm.
post hoc for equal variance
Yeah,
and
that's
not
clever.
equal
Yeah,
variance. So
that's
if it,
clever. Yeah.
yeah, and then if it's not
Mm,
equal variance, then
yeah.
I go to robust, and then from robust, I'll go to if it's equal
Mm,
variance or not, if it's
mm.
Cookie, LSD,
Yeah,
or
that's
Games
good. That's
Howell.
good. That's good
So
technique. So now we get the descriptive mean number 99, 99, 90, 91. Yeah, this right. This is the right
91.
thing. This is
Yes.
standard deviation. That's okay. So we do test of homogeneity of variant. Then we have
Yeah. And
what does this
significance
mean?
level is 0. So which no, there's
Uh,
no homos violated.
mm,
Hence, we need
mm,
to go to
mm,
robust,
mm.
the robust
So,
test.
so actually in I found that everyone everyone I may I say everyone misunderstood about this when we found that this the the variant between group is different like this means the variant between group is different and ANOVA here you can see ANOVA here ANOVA here the significant here that
Yes, sir.
mean the mean the we will accept H1 that mean mu1 not equal to mu2 not equal to mu3 that is
Two,
the
three. Yes, sir.
yet at least one.
Or at least, yes, sir. Or,
Yeah,
yeah, or at least one. It's like
yeah,
reject the null hypothesis and
right.
accept the alternative hypothesis that at least one is
Yeah,
different. So we need to do post hoc so that we will
yeah, right.
determine where the difference
And
exists.
we need to go back. Yeah,
And
yeah,
one,
right.
one, two,
We need to
two,
go back to
three.
one way again.
Yes.
And this time, yeah, and this time, most
No,
of
yes.
the most of you, oh, not this one. Most of you go back to here and click here, Welsh, and click here. But
Welsh.
I
Yes, sir.
may I say the this will give the same result. We can go now. You can see the difference. You can yes,
Yes, sir.
it will give you
It
the
also
same
gives the
result. You
same
can see
result.
the significant. This is the well. We tick well already. This is the same. This is the same. This also the same. If we can go back to see this, you can see F 41.530 and significant is 0.00. We can go to this one. You can see this is
Yes, sir.
41.530 and 60. Everything the same. Yeah. Yeah.
That's the ANOVA. That's
Yeah.
the ANOVA, sir. Because actually, sir,
Yeah.
I tried to compute the degree of freedoms
Yeah.
and robust. There
Yeah.
is a very slight difference because, like in ANOVA, it
Uh,
means that sum of
uh,
square divided by the DF is equal the mean of square. And
uh,
then the mean of square between
yeah.
divided by the within groups will give me the F
Uh,
value. But I just computed it here.
uh,
But since my
uh,
Levin's test says that my P is
uh,
less than point zero
uh,
zero 0.005, so I looked on the robust test of
mm,
Welsh. And then Welsh told me that DF1 is 2 and then DF2 is 185. So there's a little bit um a slight difference, but still my
yeah.
significance
Yeah.
level is
Right.
less than
So in
is
this
to
case, we need
still
to go back
reject
to
the
find out
null hypothesis.
which pair, yeah, which pair different. So,
Where yeah,
right. So we
where the
pick
difference
both of,
exists, if it's one
and
one
we
one
did we
two
have
or
these
two
four,
three.
right? We have these four game whole well. Yeah, and any one of
Yeah,
these, this
I
is
the
any one
I
of
click
these can be used,
the
but you need
games
to read
hall.
the detail
Yes.
from each answer. If you this is not serious, Michelle. I would like to say, anyone the same, anyone you can use. But sometimes games whole well can be used in case of they have different a lot different between group. For example, yeah, you can. Hmm.
Yes, sir. Yes, sir. Actually, sir,
LSD,
even the LSD and Tuki
yeah,
is
LSD
also
here. You
give
say
almost the same
LSD here.
mean difference with games hall.
Uh,
And because
yeah, yeah.
I click them all together
Mm,
and then I just see,
mm.
yes, the least significant difference and Tuki. I click together with games hall just to compare.
But that
And
is not the right thing because the formula, the
it's
formula is
also
different. The formula needs to, yeah, yeah, equal variance assume. But now we know, we are sure that
yes,
equal
yeah.
variance not assumed. So
Yeah, it
we
should
need to
be the
select one of these,
equal variance
one of
assumed,
these.
yes. So,
But actually, I not in this case, I am not prefer to use game whole whale, but most of you use game
yes.
whole whale. That's okay. Uh, game whole whale normally, yeah. Mm, 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 yeah, yeah,
It's maybe because of yes,
yeah,
sir. It's
yeah.
maybe because
Learn.
of Laerd.
Mm.
We all
Yeah, yeah,
studied
I
in
know that. I
Laerd.
know that because I read that, and I
Yeah,
think
maybe because of
all of you
Laerd.
just follow that website.
Many of us studied in
Alert,
Laerd.
yeah, follow that website. That's okay. But if you read the detail, game whole will use in case of the number of each
Yeah.
group just quite different from each other. For example, the first one is 20, the second one is 100, the third one is 300, something like this. If if the sample in each group is a big difference between each other, you can use game whole whales. That's all right. But yeah, hmm. uh, uh,
Ah, actually, sir, I have an
uh,
explanation there. I actually put an
uh,
explanation because, yes, I read that games whole should
uh,
have a big difference in
uh,
variance. And then I tried to explain that maybe because
mm,
if we will
mm,
judge by visual, the difference is not very big. It's even one or less than one
mm,
between means. But the reason why it is
mm,
why we think that the means are not the same because it is pH value and pH value are logarithmic. It's a logarithmic and every value difference is 10 times higher than or 10 times more basic, I
mm.
think. I just
Mm.
trying to explain, but I'm not sure
Yeah,
if it's.
yeah. That's all right. That's okay. That's okay.
But sir, if the means
Yeah.
is very small, what
Uh,
is more recommended if it's not games how well?
no, it's not important about the mean. It will consider the variance the variance
Variance.
between groups. So in case of the mean, it's very low. There's no problem if the variance is big. Mm. So in this case, if in the future you are going to use the equal variance, not assume again, you can study more for the other three. So now,
The other
yeah,
three,
yeah, the
the
other
other
three,
three,
yeah,
if the variance is
yeah,
not so different. Okay,
yeah,
so that's do
yeah,
not T3.
yeah.
Okay, the other
Unity
three.
three, Unity three, and this one. So now we use game whole whale first. Let's click continue, and then we ready now. So we click OK again. Yeah,
Sir,
yeah,
uh,
yeah.
I I should have asked you to click all
Okay.
so we can see
Yeah,
if it's different.
yeah. This is
Like click
click.
click
Oh,
click
okay. That
do not T2
okay.
click, yeah,
Okay.
yeah, so that we can
Okay,
see.
that's fine. No problem. Can go this again. Okay.
Yes, thank you,
Yeah.
sir. Yeah, click
Copy.
yeah.
Yeah.
Yes, thank
Yeah.
you.
Okay. This all you can see
Yes, yes, it's
the same.
oh, it's
The same.
still but donut C has no
No significant. Yeah.
significance
Yeah.
level.
But this is not
It's
important. You can see this. The what is the star here, italic here, italic
yes.
here. This italic
Mm-hmm.
mean the mean difference is significant at the level 0.05.
Point
Yeah,
zero
zero point zero
five.
0.05 level.
Yeah, the
Yeah, the
asterisk.
asterisk. So this is may not important, but you can see the asterisk here. All of them, all of them. So in this case, you can see the significant. This is the significant here. So that means each group different. Each group different from each other. Any technique have the same result. You can see the four technique
Mm-hmm.
here. Four technique here have the same.
24932. Yeah, yeah, yeah. They almost have the same. If maybe there's very small difference,
Yeah,
but for now it looks almost
yeah,
the
yeah,
same.
yeah.
Standard. Yeah. Mean difference I minus J. Yes.
Uh, so thi- so that's all. This is the way to analyze the data from this problem from my problem, and we can make a conclusion like we found that the H1 at the we accept H1 hypothesis, alternative hypothesis, and
Each-
each of each of zone have
Yes.
totally different from each other, and you can show this evidence any one of these.
Yes.
You can show the evidence like
And
yeah,
plot
plus the
the
mean. That's the
means,
way to
sir.
show, the way to present the the
Um,
yeah,
to
right,
show that
the mean. Yeah,
yeah,
to
to
show
show
the
it's
mean here.
different.
You can present the mean here mm, to show to the public. That's it all that we need.
Yeah.
Yeah.